Dear students, this is our second class on the chapter Differential Equations, and in this chapter we will learn the methodology or method to solve homogeneous differential equations, and then the solutions of inhomogeneous. It should be inhomogeneous differential equations. And actually, in the case of inhomogeneous differential equation, this type of equation first converted to homogeneous equation and then use the methodology that is used to solve the homogeneous equation. And you know that in our previous class we learned how to solve a differential equation by using separation of variable method. However, let us we start this class with the solution of homogeneous differential equation. So come here, the homogeneous equation. So what is a homogeneous equation? So we know that the linear equation has the general form dy by dx is equal to fxy as we learned in our previous class. So if the function fxy, that is this function, fxy has the form of f function of xy and divided by function of gxy. In our previous cases, we know that there are two functions. The function fxy is separated into two individual functions of fx, that is f was only the function of x and g was the only the function of y. But in this case there is there are two variables in this function and also in this function. So this is somewhat different from that we learned in our previous class. So if the function capital fxy in the equation dy by dx is equal to fxy is has the form fxy by gxy, in which both g and f are homogeneous. That means both of them have the same degree. That means if the degree of f is in this case 1 and in this case 1, if the power or degree of f would be here n and here n, then this function fxy would also be a homogeneous function. And the differential equation having the form of dy by dx is equal to fxy by gxy can also be called a homogeneous equation. And this equation can also be written as, since if we since these f and g, these two functions are homogeneous, that means they have the same power. So if we consider that f and g are will have the same power, that means, and that power is taken as n. If the power of g and f are taken as n, then you can write this function fxy function as, if you take x as a x as if you divide take if you take x as outside the function, that means other word is a common function, then x to the power n can be written outside the function, and then phi y, there should be another function that instead of f, that should be phi and y by x. You can write this in this fashion. This function can be written in this fashion: x to the power n phi y by x. Then this can also be written as x to the power n, then psi of y by x. And this x to the power n, x to the power n cancel each other, and this actually this essentially will give you another function theta, which is a function of y by x. That is nothing but phi y by x by psi y by x. So finally, we can achieve the differential equation as dy by dx is equal to theta y by x, and you know that theta, psi, and phi all are function of y by x, and this type of equation is called a homogeneous equation. So at a glance, in which manner you can understand that this is a homogeneous equation, and you have to check first whether that equation is given in this form or not. If it is given in this form, that is dy by dx is equal to fxy by gxy, then you can treat it as a homogeneous equation. And the solution of homogeneous equation is stated here. What is that? To solve this type of homogeneous equation, you need to substitute y by x, that is in this function within theta, this function y by x, as v. And if you once take it as y by x as v, from here we can write comfortably y is equal to v by x, or simply here from here v is equal to y by x. So that is also here, so no problem is there. So just from here you write y is equal to vx. And here you should remember that this v is also a function of x. Okay, now just to differentiate this y is equal to vx, differentiate this equation. You will have dy, the left hand side, and that is equal to v dx, then x into dv, because v is also a function of x. So you can write from here after differentiation v dx then x dv. Now that is equal to you can write this as dx, then v from here plus x into dv by dx. So finally you can write dy by dx is equal to v plus x dv by dx. And now substitute the value of dy by dx, that is equal to v plus x dv by dx in the given equation. That is this equation dy by dx is equal to theta y by x. In this equation, that is equation number 1. So you will have dy by dx. Since dy by dx is this, so v plus x dv by dx is equal to theta. Since y by x is equal to v, so it is written here v. So from here you can write x dv by dx is equal to this theta v minus this v. Okay, or from here dv by theta v minus v, that is equal to dx by x, that will be equal to this. Now integrate this both sides of this equation. Integration dv by theta v minus v, that is equal to dx by x. And after integration you can easily find out the value of v. And if once you get the value of v, then substitute the value of v as y by x, then you will get the solution of the given equation. So here are some examples from where the process, the methodology will be very clear. The first one is that here is the equation which we have to solve. It is 2xy dy by dx is equal to x square plus y square. This is equation 1, and just to rewrite this equation as dy by dx is equal to x square plus y square by 2xy. And you know that this is a function of f xy, and this is a function say g xy. So this is a homogeneous equation, and this type of homogeneous equation you have to a substitution, that is y is equal to vx. And from this relation you can easily write dy by dx is equal to v plus x into dv by dx. Now substitute this value of dy by dx in this equation, that is equation number 2. So you will have v plus x dv by dx, that is equal to this, and here just you substitute the value of y, and you know that y is equal to vx. So first term is x square, then plus v square x square, and here 2, then this x is here, and you know that v is equal to y is equal to vx, so that is vx. So just simplify it, you will have 1 plus v square by v. So from here you can write, so left hand side is v plus x dv by dx, and right hand side is 1 plus v square by 2v. And now from here you can write x dv by dx is equal to 1 plus v square by 2v minus v. And the simplification is shown here. And from here after simplification you will have x dv by dx is equal to 1 minus v square by 2v. Simplification process is given here. So from here you can write this 2v by 1 minus v square into this dv is equal to dx by x, and just integrate 2v dv 1 minus v square, that is equal to dx by x. And you know that it is written here that if you write this d of 1 minus v square, you can if you compute this, it will result minus 2v dv. So from this relation you can write integration 2v dv 1 minus v square, that is equal to dx by x. That can be written as with a minus sign, because you know that 2v dv should be minus of d into 1 minus v square. So that is here integration d of 1 minus v square by 1 minus v square, that is equal to dx by x. Or from here after integration you have log, because you know that dx by x, this has the form dx by x. So log 1 minus v square, that is equal to log x from this term, and plus log c, that is the integrating constant. So from here log x can be written as log x can be written as log 1 minus, this can be written as this can be written, log x is equal to minus log 1 minus b square, then this log c is taken here. Okay, so you can write this in this manner. So in this case you say that minus log c is equal to plus log c. Okay, this is a constant, so no matter with this. So from here log x is equal to log of c by 1 minus b square, you can write this, or x is equal to c by 1 minus b square, or x is equal to 1 minus b square, x into 1 minus b square, that is equal to c. So if you write in this case as minus log c, so that will be no problem. You can proceed with that. I have written here minus log c is equal to plus log c. That is constant. That's why. So from here x is equal to 1 minus v square is equal to c, and now substitute the value of y as vx, or v is equal to y by x. So substitute this value in this equation. So x is here, then 1 minus v square means y square by x square, that is equal to c, or from here x into x square minus y square by x square, that is equal to c. This x and that will cancel, and 1 x will be here. So x square minus y square is equal to cx. So this is the solution. And now in this solution, if you impose a condition that is y equal to 0 at x equal to 1, then what would be the situation? What would be the value of c? So if you do that, that is if you use the value of x and y is equal to 0, then you can obtain and you can find from equation number 3 that this c would be equal to x is 1 and y is equal to 0. So c is equal to 1. So writing the value of c or putting the value of c in this equation, you have x square minus y square is equal to x square y square equal to x. This is the solution. Now come to another solution, another problem, that is dy by dx is equal to y by x plus. So this is also a homogeneous equation, and to do this, to solve this equation, you have to substitute y is equal to vx, and then dy by dx is equal to v plus x dv by dx, as we did in our previous solution. So this is the case where dy by dx is calculated as this. Now substitute the value of dy by dx and the value of y, that is equal to vx, in this equation. I have done it here, and after being some simplification, after some steps, we get x equal to dv by dx is equal to minus v square by 1 plus v. Just you go through this. Every steps is calculated here, given here, so there will be no problem to understand this how this equation comes from this equation. Okay, no problem. Then now just integrate this equation, both sides of this equation. So 1 plus v by v square dv is equal to dx by x. Now this can be written as, this term can be written as 1 by v square plus 1 by v. Just calculate this, it will give you this result. And then dy by dx. Just integrate. And now you have to integrate. This will give you minus 1 by v. You know the integration of 1 by v square. And this is log v. And that will give you log x plus log c. This is the integrating constant. So in some future problem, if I don't tell that it is c is a real constant, integrating constant, that will not that will not matter, because you know that c is a constant. So from here you can write that this log v is here with a minus sign, and this log x is here, and this log c is here, and this 1 by v is here, okay, with a minus sign. So from here you can write log c vx is equal to 1 by v, and you just substitute here the value of v as y by x. After being substitution, after being substituting of the value of v, you finally get y is equal to 1 by c e to the power xy. Or from here y is equal to c1, c is another constant, that is nothing but 1 by c. So this is the solution. Now another problem is here, x square minus y square dx 2xy dy. So you have to solve this equation, and you know that this equation can be rewritten as from here dy by dx, that is equal to minus of x square minus y square by 2xy, and that can also be written as y square minus x square by 2xy. And this is a homogeneous equation, and you have to solve this equation. You need to substitute y is equal to vx, and then the value of dy by dx as this. And now you have to substitute the value of dy by dx, and y, that is vx, in this equation. Just substitute this, and this is the substitution process and simplification process. Finally you get the term x dv by dx is equal to this v square minus 1 by 2v. Just go through these lines. So just go through this. So after that, you can also write that 2v by v square minus v square plus 1. This is the minus sign will be a common term. So then v square plus 1, and this minus sign is here. So that is dv is equal to minus dx by x. Okay, no, 2v by v square plus 1 dv with a minus sign, that is equal to dx by x. Now this minus sign is omitted, so there will be a minus sign. So this is here. So now you know that d of v square plus 1 is equal to 2v dv. So this 2v dv can be replaced by d of v square plus 1. And here v square plus 1. So you know that this is the form of dx by x. So this will give you log v square plus 1. And the right hand side is log x. And this is a constant log c1. Just substitute the value, just simplify all these terms. So from here you can write log x into v square plus 1, that is equal to log c1, and from here x into v square plus 1, that is equal to c1. Now substitute the value of b as y by x, that is done here. So plus 1, that is equal to c1, or from here x square plus y square by x square into x, that is equal to c1. Just simplify this, and finally we obtain x square plus y square is equal to c1x. So this is the solution. Now another problem is there. This is y square plus 3xy plus z square dy by dx. So from here you can write that is equal to 0. From here you can write dy by dx 3x square plus 3xy plus x square, that is equal to minus of y square, and from here dy by dx is equal to y square by 3xy plus x square. Now in this relation, this is also a homogeneous equation. Just you substitute y is equal to vx, and after substitution and after simplification you will have this line. Just go through this line, and x dv by dx, that is equal to minus 4b square by b 3b plus 1. And then you need to integrate this equation, both sides of this equation, and from here you can also write 3b plus 1 by 4b square plus b dv is equal to minus dv by dx by dx. Now this can be written as 3b by 4b square plus b and plus 1 by 4b square plus b dv, and then this is minus dx by x. Integrate both sides. After integration you can find that, you can write that, you can you can understand that this integration will give you 3 by 4 log 4b plus 1, then plus 1 by b minus this term can be written as 1 by b minus 4 by 4b plus 1 dv, that is log c by x. So that is 3 by 4 log 4b plus 1 plus log b minus log 4b plus 1, because you know that the differentiation of this will give you 4 dv. So this log c by x. Just go through this, and finally you will obtain that log 4b plus 1 by b to the power 1/4 is equal to log x by c, or log 4b plus 1 to the power 4 by v is equal to you can write x by c, and this is there. So now substitute the value of v, that is y, that is equal to y by x, that is done here. So that is x by c, and just simplify. After simplification you will have y to the 4 is equal to c into y 4y by x plus 1. Just go through this. You need not to worry about the calculations, and it is very simple one. And now solve the another equation. Here is another equation is given, that is y square minus x square dx by dy plus 2xy is equal to 0, and then you can rewrite this equation as dx by dy, that is minus 2xy, or from here dy by dx is equal to y square minus x square by 2xy, and this can be rewritten as this. Now to solve this equation you need to substitute y is equal to bx, and from here dy by dx is equal to b plus x dv by dx, and now substitute these values of dy by dx and y in this equation. In this equation you will have it will have the form this. Just the process is there, and finally you will have 2v by 1 minus 3v square dv, that is equal to dx by x, and this equation and this the solution, the process of solution or process of the calculations are stated here and given here. All the steps are written here, So I think there will be no problem to understand. And so the finally you have finally you can write see here what is done here. So dv by dx into x, just substituting after the value of this, that means x dv by dx is equal to this, and to be finally we get this is also. And now you know that d of 1 minus 3b square will give you 3 dv 3v dv, or v dv is 1/3 d of this. And then from here you can write 1/3 d of 1 minus d of 1 minus 3b square by 1 minus 3b square. That will give you in the form of that is equal to the in the right hand side dx by x, but this minus sign is taken here. So after that, from here this is the next line. This is 2/3, and this will provide you log 1 minus 3b square, that is minus log x plus log c1, or 2/3 log 1 minus 3b square is equal to log c1 by x, or log 1 minus 3b square to the 3 2/3, that is log c1 by x. And then just go through some simplification, and finally we'll get x cube is equal to 3xy square plus c. This is another solution, another equation which you have to solve. That is xy plus x square minus y dx is equal to 0. And and you can observe here or see here, or of the in the study material that I will provide you. Just go through. The process is the same. Here you have to rewrite this equation in the form of dy by dx is equal to a function of f xy and a function of x in this way xy. So in this case the function here there is no term including y, so no problem is with this. So just you have to this is however this can also be homogeneous equation. So you can solve this with substitution of y is equal to vx, and then dy by dx is equal to this. And now substitute these values in this equation, in this expression, then you have in the right, then you have finally dv by dx is equal to minus 1, or dv is equal to minus of dx, or from here minus x plus c. So from here you can write y is equal to, just substitute the value of b here, y by x, this, so y is equal to x square plus c. So this is this is some examples, and another example is here, another problem is here. To solve this equation you have to, this is also and you can write dy by dx is equal to y square by x square minus y by x. So this is also a homogeneous equation, and you have to employ the same methodology. So that is you have to substitute y is equal to px. Just do it, and the value of dy by dx, substitute this value here, and in this equation expression you use the value of y is equal to px. So after doing that, the left hand side will provide you x dv by dx is equal to v square minus 2v, and then dv by v into v minus 2 dx by x, and that can be written, this can be written as half 1 by v minus 2, then minus 1 by v dv dx by x. Just integrate this. After integration you get log v minus 2, then minus log v, that is equal to 2 log x plus log c, and that is equal to, you can write it as this 2 log x can be written as log x square, and this will give you log c x square. And from here you can write b minus 2 by v, that is equal to c x square. And now the time has come to substitute the value of b as y by x. So do it, and after doing it you have finally obtained y is equal to minus 2x, that is equal, and that is equal to cy x square. And from here y minus 2x is equal to cy x square. So in this class till now we have learned how to solve a homogeneous equation, and the solution of inhomogeneous equation will be discussed in our next class, because the length of this class will be much longer, it will be much lengthy. So we will discuss the solution of inhomogeneous equation in our next class. So this is the end of this class, and you need to go through all these calculations, and you have to practice. And if you do it once, then every thing will be very clear to you, and you can solve this kind of equation in your own effort. So This is the end of this class.